Okay, so the last type of graph that we're going to look at here is when we're graphing over a domain of all reals. And that's where we're going to graph the entire function. Nothing is taken out, no open and closed circles. We're going to have arrows on things. And so that's what's going on. So we're going to start the same way we always do. We got to create our table and we're going to look at the function in the calculator so we can see what it's supposed to look like. In terms of what values go on your table, my rule is if the point fits on the graph, the point should be on your table. And the reason is very simple. The more points that we have, the more accurate picture we can graph. If we have less points, now we're kind of guessing. And that what happens is we end up in a situation where the graph takes on an incorrect shape. And so we want to avoid that. And so the best thing to do is to just put as many points as possible. So I am creating my table and all of these points fit on my graph. Don't have to worry about open and closed circles. So the next step is to start graphing. 3, -1, -2, 4, -1, 7. And the nice thing about a quadratic is you can come right around. It's a mirror image, which is really nice. And I did look at it in my calculator and it was a nice smooth curve. Now, so when we connect the line, and we do connect the line with this because I want all the values, we're going to go all the way to the edge of our graph paper. So now we're not stopping anywhere. We keep extending this all the way to the edge of the graph and we get arrows on both ends. And notice that the more points I had, I was able to draw a pretty accurate picture here. Domain and range, we should be pretty familiar with this by now. So range is bottom to top. So it asks us to state the range. We'll do that with interval notation. This has an arrow heading downwards. So we know that the bottom of this is at -infinity because that's the lowest that it goes is -infinity. And then it does have a top on it. And at the top is at 8 and it actually touches 8, so that gets a bracket. So draw the entire function all the way, put as many points as you can on your table so that you get the best picture possible. And it's quite likely that when we're graphing over all reals, our range is going to contain some infinity symbols. That's quite common. Now, all three of these, you will notice, have arrows on both sides. Arrow, 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 arrow. That means that the domain for each of these is all reals because it goes to -infinity in this direction and it goes to +infinity in this direction. And that's true for all three of these. -infinity in that direction, +infinity in that direction. -infinity in that direction, +infinity in that direction. So the domain for each of these is -infinity to +infinity, or you are welcome, if you prefer, you are welcome to actually write all reals. That means the exact same thing. So you can do that if you want to. Ranges are bottom to top. So in this case, bottom at -2, it actually touches -2. And then we see the arrow going in the positive direction. So this goes to +infinity. Here, range, I notice that this is a line, which means it's going to go down forever. So this goes to -infinity to +infinity in the upward direction. Arrow on the right-hand side means we're going up forever. Now, this one, I left the name of the function in. This is an exponential function. And remember, that's the one that's a little bit different. What's happening on this side is I'm getting closer and closer and closer to the x-axis, but I never cross it. So the range for a exponential function is 0, but it doesn't touch 0. And then it goes off to infinity in the positive direction. So what you have to recognize is you have to recognize this shape. This is the only one that we're going to worry about for now that has that weird property. So I know you see an arrow, and arrows usually mean to negative infinity, but not in this case. In this case, this is an exponential function, and you have to know that it gets closer and closer and closer to the x-axis, but doesn't actually touch it. So be careful with that one. And that's it.